Hello students, this is Yashodhari. In this video, we know about the 3D transformation. Okay, so let's start. We know what is the transformation, right? It's a process to change the given polygon in the form of you can change the size or the angle, or you can say a scaling of any given object. You can increase or decrease the size of a given object, right? Translation, which is change a place of a given object, a location of a polygon. Okay, so we know about the what is a transformation, right? So in this video we focusing on how the a 3D transformation will be work on a in a computer graphics. Okay, the when the transformation takes place on a 3D plane, means 3D planes is nothing but you can a transformation will be occurred on the x-axis, y-axis, and z-axis. That is called a 3D plane. Okay, so this transformation is called a 3D transformation. Transformation nothing but is a process where change or manipulation the a given polygon or a object orientation. You better know what is the orientation of an object, that is you can change in the form of a position, angle, or a size. With homogeneous coordinate, it is main thing. Means in a 2D, it's a worked on a 2D plane. Here for 3D, we are working with a using a homogeneous coordinate. What is a homogeneous coordinates? You will know, right? It is having a extra coordinate which represent with the h or a w. Okay, that value will be standard one, that is 1. Okay, we adding the 1 coordinate extra in the 3D for 3D and 2D. In 2D it will take the 3D, means 3 vertices, right? In a 3D you can take the a matrix of a 4 into 4. Okay, so next point we have to focus here. In 3D, each transformation is represented by a what? A 4 into 4 matrix. Why it is become 4 into 4? Using the homogeneous coordinate, it becomes a 4 into 4 matrix. Okay. It is possible to represent each type of a transformation in a matrix form and integrated transformation into one matrix. What is a integrated? You can say integrated or in a composite transformation. In composite means you have to combining one or more than one transformation process in a single matrix. That is called a composite or a integrated transformation. Okay, I hope this is clear. Now, next point, in same as in a transformation of 2D, we perform a translation, rotation, scaling, sharing and reflection, right? Same the transformation process we done in a 3D, okay? That is a translation that changes the position, scaling that increase or decrease the size of a polygon, and rotation we changing the angle of a given object. Okay, reflection gives a 180-degree, or you can say a mirror image of a given object, and sharing it will tilt the half diagonal, will say the given the object in a half diagonal, you can say, or shield. Okay, just a bend of a given image will be given. Okay, so this is about a 3D transformation where the a matrix is represented with a 4 into 4. Okay. So first we see a translation, right? We know we learned in a 2D transformation the translation, how the translation works, right? Here it moves moving every point at a constant distance in a specified direction. It is of a the grid motion. Grid motion means something changes. Okay. So in the manner of a location we are changing. Grid motions include a rotation and reflection mode. Okay, basic formula we know. Translation equals to p dash plus of a v. Here v is nothing but our vector. So translation is an of a transformation but not a linear transformation. With the homogeneous coordinate are normally used to represent the translation operator by a matrix. Thus, we write a 3D vector in a 3D vector means nothing but your the coordinates. Here W we are taking as a homogeneous, that is W of x, W of y, W of z. With homogeneous it will indicate with the 1. Okay. So the translation of an object by a vector. Here vector is nothing but your p dash or a p where points we are taking. So vector t of x, t of y, t of z. X coordinate of a translation, y coordinates of a translation, z coordinate of a translation. With homogeneous we are represented with the 1. Okay, it understood, right? So for this would need to be multiplied by this translation matrix. So using homogeneous, here 3D, 4D will be coming. This is your matrix representation of a normal translation. To desired result is obtained by applying a translation matrix as this is your, we can write the P as a xy z1 or it's a matrix of a with homogeneous we are calculating, so that's why translation becomes for addition it becomes a multiplication. Okay, this is a normal of a addition of a translation. Okay, once we apply the homogeneous coordinate in a 3D vector or a 3D, we get a 4 into 4 matrix, so it will help to perform a composite transformation. Okay, this is an example of a translation along a wire V we can take. Okay, in a rotation, 3D rotation. In 2D, we are performing a rotation on a clockwise, anti-clockwise on a x-axis or y-axis. Here, we are taking the help of another object, the coordinates or you can say vector, that is a z. The rotation needs an angle and an axis. So, rotation is defined according to the right hand rule. In 3D, here the A will should miss here. So right hand rule in 3D rotation is about a vector which we can be done through rotation about, you can say x axis, y axis or z axis. So how the matrix will be written? This is an example of a x axis and y axis and z axis. The rotations are orthogonal, means how the projecting that objects, that is presented distance angle. So on about rotation about x axis means x value have to 1 and y and z. We can write down the matrix this one. Okay. Rotation about y axis, y should be 1 and x and z coordinates were assigned with the matrix like this. Okay. And homogeneous is 1. So for that 3 into 3 it becomes a 4 into 4 matrix. This is about a y-axis and rotation about z-axis is a 1 1. Okay, homogeneous is 1 and z is coordinate or vector is 1 and x and y, here the cos theta sin theta minus sin theta cos theta and remaining are 0. Okay, so this is how we have to write down the matrix like this. And equation we know the about rotation about x-axis, x dash is x, y dash is y cos theta minus z sin theta. Like this you have to write down. And y about y-axis, it's a y dash is y, x dash is x cos theta plus z sin theta, and z is z dash is z cos theta minus sin theta. If rotation about z axis means x and y are the x cos theta minus y sin theta, x sin theta minus of y cos theta, and z dash is z. So this is how we have to write down the matrix and equation of a 3D rotations. Okay. So this is a representative means rotations of angle on a about the z axis. This is about a x-axis and this is about a y-axis. So in next video we know about the another types, that is a scaling and a reflection and sharing will discuss in next video. I hope the concept is clear. Here I just mentioned the matrix, how we have to write down the matrix of a 3D using a homogeneous. Okay. Thank you.